I'm on a mission to build the most efficient self-propelled vehicle to make personal transportation affordable, easy and eco-friendly. Here I'm sculpting the body. If you're planning one day to design your own vehicle, this is one way to make the vehicle's body. The material I decided to use for the body is expanded polystyrene, but there are many other material choices you could make based on different needs. But usually for this kind of projects, polystyrene is a very popular choice. There are fundamentally two types of polystyrene, extruded and expanded. Extruded polystyrene is more expensive but also more rigid, and the grain structure is smaller, allowing you to get a higher level of detail. Expanded is less dense, therefore with a larger grain structure but also much cheaper. For my project, I choose expanded polystyrene for the lower cost and because I don't have intricate shapes. In my case, the expanded polystyrene was about 3 times cheaper than the extruded, so there's a big price difference. I spent about 180 euros and the expanded one was about 500, so there's a big difference. One tip of advice, if you want to get really drunk, take one shot every time I say the word polystyrene, but before you watch this video, call an ambulance because you're probably going to end up in a coma. So, the polystyrene used is 10 centimeters thick. I made 4 sections with 12 layers of polystyrene, adding to a total height of 1.2 meters. Coincidentally, the same height as the body of my vehicle. All the 4 sections were then glued together to make the volume I needed to sculpt the vehicle from. To glue the polystyrene, I used foam. If you do this, it's a good idea to use a type of foam designed to glue insulation. This foam doesn't expand as much, so the gaps between the polystyrene boards stay small. I decided to go for this method with the 4 sections glued together so that I could have a horizontal line every 10 centimeters, created by the layer line between the boards, and a vertical line splitting the body in the middle. These lines are useful as indexing points to help with dimensional accuracy, and especially after doing the first half, the vertical and the horizontal lines are useful to copy with accuracy the second half of the completed first half of the body. When you are creating something that needs to be symmetrical, you make the first half as you wish. And this is also the fun part. And then to copy accurately the first half is the tedious, boring part of the job. At least it is for me. Some may like doing that. But mid-project, I decided not to make the second half anymore and finish only the first half of the body. But why? Usually, how this is done, you make the entire body as perfect as you can manage. Then you make a fiberglass copy that you lay on top of the body, that's called the negative. You pull that from the sculpture, and in the negative mold, you make the final fiberglass part. This process is good if you are sure the body you make will be the final version. Otherwise, even small changes, you have to redo pretty much everything again. And I'm sure there will be lots of changes, since the first prototype is never perfect and I'm not looking forward to redo this over and over again. It takes a huge amount of time and it's expensive. So what are other ways in which this can be done? There is this exciting technology called 3D printing. It's really good for prototyping since you can make accurate parts, try them, test them before committing to making the final fiberglass or metal parts. Or, if you have a higher performance 3D printer, you can use some filaments that approach the strength of aluminum and use the 3D printed part as permanent. With a 3D printer, you can also print big parts, like for example a car door, by printing the door in smaller sections, then gluing them together, achieving a complete door. With 3D printing, I can achieve accurate parts, and making the body symmetrical is actually trivial. So I bought a 3D printer, a Creality K2 more precisely. This one is one of the more expensive printers, but I decided to buy this printer due to the large print bed and temperature control chamber that allow you to print with more difficult so-called engineering filaments. The printer with about 15 kilos of filament and a lot of spare parts cost me about 2,000 euros. Usually, people who have printers keep the physical sculpture of the body and design it in a 3D software, then directly print it. I decided to still go through the hassle of making a physical sculpture and not just rely on a computer 3D model. But again, why? This is mostly my pet peeve, but I think objects don't look the same on a screen since you see a 3D object on a two-dimensional surface. It's not a given that something looking good in a picture looks good in reality. For example, I have an Alfa Romeo GT. This car in picture looks awkward, especially at the back. I remember seeing it in the magazine when it was launched and wondering how could Alfa design such an ugly duckling. But when I saw it in person, I fell in love with the design, and after years, when I found a good one for sale, I actually bought it. I think that the car looks much better in reality than it looks in pictures. I think for what I'm doing, having a physical sculpture is even more important. Vehicles with ergonomic design tend to look a bit like blobs. I wanted to make sure that my vehicle is enjoyable to look at, that it has character and that the design looks energetic, that the shapes feel good when you run your hand across them. I understand these terms can sound meaningless, but I think they represent what my goal is. After finishing the rough shape in polystyrene, the time came to make the surface rigid and smooth-ish. You'll get the ish a bit later. I used gypsum to create a harder shell. There are many different types of gypsum and I don't know the difference between the different kinds. If you want to do something like this, go to your local store that sells construction materials and ask for gypsum that takes a few hours to harden and that doesn't crack when it's drying. I applied a few coats and between every gypsum coat I refined the surface until I got something with the shape I wanted. But I left a fairly rough surface. The rough surface is necessary for the consequent 3D scanning. I don't have a 3D scanner yet because they are fairly expensive, but on my research about them I found that 3D scanners struggle with very glossy, very smooth surfaces. A rough shape is better for 3D scanning because it has more points of information from which to build the 3D shape. At least that's how I understood it to work. I might be wrong. A 3D scanner is definitely on the bucket list for future upgrades on my vehicle creating tool chest. But because good ones are expensive and my ancient laptop can't run one, I'll have to wait a bit before getting one. And what's the reason for the sharp line in the middle? When I'll eventually 3D scan the body, the line is useful to delineate the exact half of the vehicle. This way I can easily mirror the body correctly to get an accurate 3D shape that I will then 3D print. It was easy to cut the line accurately because I used the vertical parting line between the two polystyrene halves. If you had enough patience to watch until here, I wish you a good day. I'm looking for investors or people who want to help with funding this project. I believe a vehicle like this is necessary to reduce the pollution we are causing by using cars. If you like what I'm trying to achieve, a bit of help would make a huge difference. If you want to reach me directly, I have my personal email in the video description. Wish you all a beautiful, fantastic day full of love and goodness. Bye bye.